Hi, my name is Jennifer, and in this video, I'm going to show you how to rationalize the denominator of radical expressions. So grab a pencil and some paper and work through these problems with me. Let's take a look at our first example. We have the square root of 1 over the square root of 5. The first thing I want you to notice is that neither the 1 or 5 have any other factors in them. So we can't break them apart, or we can't take the square root of them unless we had a calculator. So we're going to have to do something else to simplify this. Because in algebra, it's actually improper to leave a radical sign in the denominator. So I'm going to show you a way of removing that radical sign from the denominator. It's called rationalizing the denominator. So what we're going to do is we're going to multiply this fraction times another fraction, but we get to decide what that other fraction will be. So here's what we're going to do. I want to multiply this radical 5 times another number, which it also has to be in a radical sign, so that this 5 turns into a perfect square number. Because once it's a perfect square number, we can take the square root of that number, and the radical sign goes away. So we're going to choose that same number, radical 5. We're going to multiply it to the numerator and the denominator. And we can do this because the value of square root of 5 over square root of 5 is 1. So we're not actually changing the value of the problem. Next, because both of these numbers are under a radical, we can multiply those straight across. So radical 1 times radical 5 is radical 5, and radical 5 times radical 5 is radical 25. Next, we can simplify this one more time. We'll come down here. Radical 5 cannot be simplified, but you should recognize that 25 is now a perfect square, and the square root of 25 is 5. Now, even though you see two 5s as part of your answers, because this top 5 is inside of a radical, it's not actually a whole number of a 5. So we cannot simplify it with the whole number 5 that's on the bottom. But we were successful at removing the radical from the bottom, so our final answer is radical 5 over 5. Okay, let's try another example. Take the square root of the fraction 1 over 10. Now remember, when the square root symbol is over an entire fraction, let's first see if we can simplify the fraction on the inside. This one is 1 over 10, which can't be simplified, so we're going to go ahead and move on to the next step. The next step is to separate the radical into two radicals. So we have the square root of 1 over the square root of 10. Next, it's improper to leave a radical symbol in the denominator, so we're going to go through the process of rationalizing the denominator. We're going to multiply this fraction times another fraction so that it produces a perfect square number on the bottom. The easiest way to do that is to multiply it by radical 10 over radical 10. Next, square root of 1 times the square root of 10 is square root of 10. Square root of 10 times square root of 10 is square root of 100. We can't simplify the square root of 10, so it will remain on our top. But the square root of 100 is 10. And once again, even though we have the same numbers, 10 and 10, because the 10 in the numerator is underneath the radical symbol, it's not truly a whole number 10. so it cannot be simplified with the 10 in our denominator. So for this problem, the final answer is the square root of 10 over 10. Okay, let's take a look at this problem. We have 5 over the cubed root of 2. Now we're going to go through the same process because we're not allowed to have the radical symbol in the bottom, in the denominator. So we're going to rationalize this expression. We're going to multiply this fraction times another fraction. But because we have a cubed root symbol here, we're going to have to keep a cubed root symbol as part of our fraction. Okay, next, let's think about this. We have a 2, and we want to multiply it times a number so that the answer that it produces is a cubed root, a perfect cubed root. Okay, so we're going to multiply, if we already have 1 2, if we had 2 more 2's, we would have a set of 3, which would give us a cubed root. So we're going to multiply times the cubed root of 4. In the numerator, 5 times the cubed root of 4. Because the 5 is not inside of the radical symbol, he stays on the outside, and the cubed root of 4 just sits right next to it, over the cubed root of 2 times the cubed root of 4. Because they're both cubed roots, you can multiply straight across to get the cubed root of 8. Next, we're going to simplify this. The top is actually going to stay the same, 5 cubed roots of 4, because if you were to make a factor tree of 4, there's only 2 2's in 4, and we have a cubed root. However, when you simplify 8 to 4 times 2 and 2 times 2, notice you have a set of 3 2's. 8 is a perfect cubed root. So the cubed root of 8 is 2. Now this is our final answer. And again, even though we have a 4 in our numerator and a 2 in our denominator, because the 4 is underneath the radical symbol, it cannot cancel with a number that's on the outside of the radical. So our final answer is 5 cubed roots of 4 over 2. If you have any questions about this topic, please contact your professor or stop by the Math Tutoring Lab or watch this video again.